Okay, so people are still coming in, but let's start. So, hey everyone, I'm Daniel Lindau. I'm the Technical Director of Professional Services at Curity. And we have a webinar today, which is a joint effort with Apiable. We're going to talk about API keys and why you hopefully shouldn't use them at all. But I got Alan Knabe with me here from Apiable. So do you want to introduce yourself?
Hi, Dan. Yeah, I'm Alan. I'm the CEO and co-founder of Apiable, and we're Curity partners. We handle the API portal that maybe sits above Curity or above your API gateway.
Nice to have you here. I hope
Thanks.
we'll have a good discussion around API keys here, and you will see some demos from both our ends, and hopefully we can answer some questions from the audience as well. But let's just kick it off. So, Alan, you had a quite recent blog post around API keys and security and APIable, where you kind of say that the API keys leaves you vulnerable. So could you walk us through why you think that?
Yeah, I think at its core, what we're dealing with is people see API key, and key especially is something that you think of as a security thing, right? You know, it gets you through your door, and we call them API keys. The problem is that an API key is more, I think of it as a API consumer identifier, right? So in the underlying API gateway, the API key is generated, which says, okay, if I get this API key, I know who's making the call. And this is important because we want to do things like rate limiting, right? So we want also to have, log files to say, okay, what this developer did, how many times they called the API, and so on. But fundamentally, like I said, it's more like a consumer identifier to say this is the person making the API call. Now, the vulnerability comes from the fact that API keys don't really ever get regenerated, right? They're like a long-living thing, and they should be as well, because we want to track over time a particular developer and what they do. So an API key can live for like 5 years or so. Imagine having a password that you never reset effectively, right? We got used to the fact that we reset our passwords every month or 3 months, but API keys generally never get reused. And that kind of brings us on to this question of like, well, if you're not going to use an API key, what should you be using? That's where we get into like access tokens. And well, Daniel, why don't you tell us a little bit more about access tokens and why they're better than API keys?
Yeah, so as you said, API keys are typically static identifiers. They represent the application that it's calling you right now. It doesn't really hold any more data than that. It's you get to know who supposedly the caller is. I say supposedly because API keys are also uh, more often leaked than other uh, systems like access tokens, since the way they are being used is not standardized. They can be sent in a header, they can be sent in a query parameter, can be sent in a body. Quite often they get checked into GitHub repositories. They're easier to get a hold of, and people tend to be not as careful with them as with other types of credentials. Because of the nature. The nature is that it is only an identifier, whereas access tokens are more on the verge of a credential. They're obtained by using standardized protocols that can be uh, more secure if you need it. They can be quite easily obtained if you need it that way as well. But access tokens in an OAuth and OpenID Connect context can also hold other types of data. They can hold runtime data. They can hold information about the identity of the user currently using your application, can hold up-to-date roles of that user. And the access token is also not typically a long-lived token like an API key is. Can be shorter the lifetime of it can be shorter, and the protocols also specify how to refresh it when it expires. So the nature of the credential itself make it more secure, but also the protocols on top of it make it easier to make sure they are authentication and not just identification. So this is probably not news for people in the call right now. Most people know that API keys are not secure enough for most use cases. So why don't more people use access tokens instead of API keys, do you think?
Well, I would question that statement that most people in here kind of realize. I'm sure there's at least one person in here who's like, "What's wrong with an API key, right? It's secure, right?" So a lot of it is education, right? I think we still have a lot of education to do. The API gateways out of the box kind of come set up to deliver an API key, right? And people are like, "Okay, this is the way you do it." So a lot of organizations need to educate themselves to say, okay, API keys aren't secure. You should be using, some kind of OAuth2, client credentials, generating tokens that are refreshed, like you were saying, on a regular basis. I mean, another reason is that it's more complicated, right? An API key to try out an API, as I will demonstrate in a few moments, is really simple, right? So using API keys means that the chances of you getting an external developer to use or an internal developer to use your APIs is higher, right? It's very, very simple. Yeah, and of course that does lead to checking API keys into code repositories, as you've mentioned, right? So implementing a full, client credentials flow to generate tokens and refresh them takes more work, more handling of tokens. But with that, you get more security as well. So on that vein, why are tokens more secure specifically?
Well, as I touched on, the security lies in the protocols. So they're standardized, and the way you obtain them are specified so that you can have multiple levels of authentication of your application. So obtaining these tokens from an authorization server is pretty secure. If you have highly sensitive data, you should probably use a higher security method than just calling a weather API. But there's all these levels that make them different kinds of secure. Another good thing with the API, with access tokens is that they're, depending on the format of the token, they're also validatable by just looking at it. If you're using JSON web tokens, for instance, they are at least signed usually, and they can be encrypted. But if they're signed, that means that anyone with a public key can validate that this source that is coming from the attributes in the token actually came from a trusted server. That's not the case with the API keys because the server issuing those is the only one that holds that data. And so why that might not be part of why it's more secure, but it leads into why these things are more usable, I would say.
Mhm.
But in your product, I'm aware that you guys are making it easier for people to use access tokens instead of API keys. So how can you do that?
Yeah, well, I think an example is in order. Let me start sharing my screen, and we can take you through how we use Curity to make things more secure. Okay, so I'm in the administration dashboard of Apiable. This is where we set up our API portals. We connect API gateways, and we create API products. So I'm going to start here on the API gateway integration part. So bear with me for a second, but what we can do is say, okay, when we connect a new API gateway, we can specify the level of authorization we're going to have on this API gateway. So in this case, you see that this gateway, which is connected to AWS Stockholm, I have a very simple API key. and that's it, right? I have another gateway which is connected to the Curity server. And we can see like immediately when we add Curity that you have like higher levels of security available to you. You have OAuth 2 code flow, which is very secure, client credentials, and a pre-generated token. So I'm going to demonstrate a couple of these in the application. So what we try and do immediately for customers is say, okay, a configuration owner or security member within the organization is going to say, okay, the policy for our organization is that we only ever support, client credentials and code flow, right? So that's like, two higher levels of security. We won't do pre-generated tokens. We won't do API keys and so on. So that's kind of the starting point where we get to. I'll show you like a real life implementation of that is that when we go to a product, I have a couple of demo products. I'm going to choose the payments product. And we're going to take a look at some product plans. These are open public APIs. And I got 3 plans. I got free, advanced, and unlimited. Each of these plans has a different level of security, right? So one has an API key. This one has client credentials, and this one has a pre-generated token. So I'm going to take you through these. The free API, as you can see, has this basic auth API key. Now, one of the things we did with Curity was we used their API security model. And you can see over here, we have a link to it within the application to say, okay, how we classify the APIs. And we classify an API key as red, unsecure, right? Basically, don't use it unless it's weather data. Weather data is fine because everyone can go outside and see what the weather is, right? You don't need a secure token for that. An API key is fine. So this is something that's we're doing with Curity in this case. I'll jump across and show you this one working in the API portal. So I'm already logged into the portal. I hope the demo gods are kind to me today. And I've already subscribed to some plans so that we don't have to go through that process. But I have an API key here in my plan, right? So I've made a couple of trial calls already, and we can have a look at this. I'll regenerate it after the demo. But here we have an API key. And I'll show you that working against documentation. So I can go to documentation. The API key has already been applied in this case. So all I have to do is go here. And this is how simple it is to use an API key. If you try, then you get the API working, right? And this is my favorite API of all time. This is the jokes API. Why did the Python data scientist get arrested at customs? She was caught trying to import pandas. Oh, importing pandas. Yeah, okay. You've got to be pretty geeky to get that one. So forgive me for that one. So this is really simple, API key usage, and you can see why so many people like to use them because you can try out the API very quickly, right? If we go back to my administration dashboard, I'm going to go to a different plan. Let's have a look at the advanced plan for just a second. On this one, I have security set to client credentials, which we're sort of calling Amber, again, against this API security model. And in this particular case, we're using client credentials. I have some more available that I could choose from, but I'm choosing for this plan client credentials. Let's have a quick look at that in the application. If I go to my subscriptions, that was the advanced one. And here you can see that the user interface has changed. The developer is now seeing client ID and secret, right? So using those client ID and secret, the developer takes that and generates themselves a token, right? And the token can live for 2 minutes, 5 minutes, 1 hour, 1 month, whatever you decide to set the token to is how long it lives, right? But you can see that we're refreshing tokens and it has a life cycle. And yeah, that's a little bit more work, but ultimately leads to a much more secure application. The final one that I'm going to quickly show you is a little bit of a workaround for this demo, especially is that I can pre-generate a token, right? It's not that secure, but it's better than nothing. So we're going to pre-generate a token, and that's the one we're going to use to show the flow on using a token. So if I go to this unlimited plan, here I have a token, right? So it's not an API key, it's a pre-generated token. So I can see it and it looks different to an API key. It has like underscore here, but quite similar to a API key. But the difference being this one, you can regenerate it and it can change, etc. But just to go to documentation, I'm going to go ahead and set this under the authorization. And I'm going to do a different API this time. We're going to do a picture of the day. So we've got in the authorization header, we've got the token is now set. So quite similar to the API key. So let's try it. Hope this works. Yes. Okay, so we got our API response. This is the astronomy picture of the day. And we can go ahead and see what that is today. Lunar eclipse. So that's the picture of the day's lunar eclipse. Very nice. If I were to remove that, let's try that one. If I remove it and try it again, I'm getting an unauthorized response, right? So the token isn't present and it isn't working. So just to illustrate this, and this is a good segue into talking to Daniel about how we did this. So we got a token, but how do you kind of match that then into the underlying gateway? If I take my subscription, I got an ID here in the header. It's a little bit of a cheat for me. I can go to the underlying usage plan and find it here. So you can see this is the usage plan, and this is the subscription, which is like the instance of the usage plan. And if I hover over the API key for a few seconds, you can see that the value there is an API key. It's not a token. So the question is, how did we go from using a token to then it landing here in AWS in this case and counting against my quota for the month, right? So that's kind of the question there for Daniel on how that happens with Curity.
Sure. So I thought we should take a look at how to manage your tokens in Curity a little bit, and a feature we call the token designer. So as we said, one of the benefits with the tokens over the API keys is that the tokens themselves can hold data. And in this case, I'm guessing your tokens is holding a API key that in turn then AWS can use to deduct from your quota, right? So in Curity, we have the scopes and claims editor or the token designer. So in Curity, we connect scopes to claims. A claim always belongs to a scope, an OAuth scope. So for instance, the OpenID defines a few of these scopes, the OpenID scope and the email scope. So we can see that the email scopes has two claims called email and email verified. You can also see what tokens these belong to. They belong to the ID token and the user info, but not in the access token. So this means a client requesting a token with the scope email will get an ID token with the email claim in it. They will also get an access token, but that token won't have the claim. So to the left, we create these scopes, and in the middle, we define the claims. And each claim, we can decide how to obtain the value for it. So in this case, I'm looking at the email claim, which is configured to use a claim value provider, which is looking into an account manager. So the email claim is taken from the user that authenticated, and we look into the account of the user and take the email out and put that into the email claim. And these will only appear in the OpenID tokens, the user info and the ID token. So I'm going to demonstrate this a little bit, and we can go back to the screen again. But I'm going to use OAuth tools. If you haven't heard of it before, this is an OpenID and OAuth client that implements all the OAuth flows to obtain those tokens, and making them visible for developers so they can fiddle with the protocols and try to learn and understand how these works. So I've pre-cooked my environment a little bit. So this one is talking to my development server right now, and I've registered a client called OAuth tools. And in the first box here, I can fiddle with the request that is going to be made. And this is a code flow, by the way, if I didn't say that. So the OAuth code flow, meaning I will authenticate a user while doing so. I have a drop down here to decide what scopes should I ask for. So let's start with keeping that as OpenID, which will mean that I will give both an access token and an ID token. And I can do more configurations here, like deciding what authentication method, if I should trust on SSO session and whatnot. But all these session settings ends up in the second box, which is the actual request that we've made. So when I press run here, I will start a code flow against my Curity server. I press run, and I get redirected over, and I had to log in. So I get to select from 2 different authenticators. I'm going to use the username password one and log in with my user Teddy. I logged in, and I got issued 3 tokens. I got the access token here, and I got a refresh token to use when the access token expires, and then I got an ID token. And the ID token is decoded for our viewing here. So we can see that the subject, somewhere around here we got subject Teddy. So the user that logged in right now is Teddy. It is delivered in an ID token for the application to use in your sessions or something like that. And there's also an access token that is meant to use against your APIs. So this access token is of an opaque format, so the client won't see the contents of it, but the API or an API gateway can introspect this token and see the contents of it and use that in their authorization decisions. So OAuth tools make this easy, but by having this introspect button, so I can validate and check what's in it. So we can see here that we have an OpenID scoped access token that was valid with the subject Teddy. So an API receiving this access token can say, well, it's Teddy that's calling us. He's making a request to some API that only requires a username. So this is fine. I can allow this call. But many times there's need for more data, like profile data or group memberships or something like that to authorize an API call. So that's where the token designer comes into play. So if we check again on the email claim, I didn't see that email claim because I only asked for the OpenID scope. But let's say I want the email claim in the access token as well. All I need to do is to drag and drop this into the access token and then commit my changes. And we can see what happens. I'll run the same thing again, but I'll also add the email scope since the email claim was attached to the email scope. I'll run and log in again. And I got new tokens. So we check out the ID token first. We see that we got both the email claim and we also got the email verified. So when this user created the account, then didn't verify the email. We can also check the access token to see that we have an email claim. Where is it? There it is. So by drag and dropping it into the access token, I also get access to it in my access token. So this is very handy for authorization decisions for an API because it will receive the token and can validate the token and see all the contents of it and make the decision if I should allow this call or not solely based on the request and the token itself. Yeah, that's pretty much what I wanted to show. So I'll stop sharing. And I saw that we got a question in there.
Yeah, I think this is a question more for me. Isn't there a security issue when we expose the client ID and secret in the browser, given that it shouldn't be leaked? Ultimately, at the end of the day, the developer has to get the client ID and secret to use it. But everything is encrypted. You know, it's HTTPS is being used on the website when the developer is logging in, so they're getting secure access. And we also have the possibility to change that so you can just like copy the secret without actually ever exposing it through the browser to paste it into your own application. So that's how we handle that. But anonymous attendee, happy to get into more of a detailed discussion on that one. I have a question for you, Daniel. It's about the is it possible to have information on the token that it could potentially be used like externally and go to a developer and they get access to the token, but they don't get access to like say it's an internal identifier of the user, something like sensitive that you wouldn't necessarily want an external to see, but you want to then be able to see it internally. How do you handle that kind of process?
Well, I would handle it the same way we did with the email claim. Basically, we put it into to a token, which will make it available for the APIs and gateways. The difference is the way the value is looked up. So it for instance, you have a user identifier on your account that no one outside of your organization has any meaning to. We can look up the account before issuing the token and stamp it into the token and send it out to the APIs without the user itself knowing it, and the client, the application or client wouldn't ever see it. We just put it into the access token, so it's on the internal side of the network.
Okay, so that's how it's hidden.
Yeah. It's we've had other webinars on the subject, but the phantom token pattern is something that people can look into, because that is kind of meant for hiding that type of data, and that's typically what I showed you. The applications and clients, they only get an opaque token, which is a random string, the same type that you showed in your UI, that you can hack on for as long as you like. You won't find any data, but only clients that are allowed to validate and introspect this client is able to get the actual value of the token, which is typically only given to a API gateway of sorts that can then verify, get the data, and in most cases they can get back a signed JSON web token to send to the API instead. But that's a broader topic for a different kind of webinar, perhaps. It's good to know that it's out there.
Yeah, yeah. And I believe, just like winding this down, we will also send the API security maturity model. That's the one that we basically used in order to categorize the different levels of API security using Curity in that case. So you guys will get that as a link there as well, I believe. Other than that, feel free to reach out to me at Apiable. I think we're going to post a link as well to our security section on our website. Yeah, thank you very much.
Thank you, Alan. It was great talking to you.
Yeah, likewise. Thanks, guys.